we are starting with the concept of mensuration. And in mensuration, let's first get started with the idea about circle, and then we have arcs, and we have sectors, and so on. So we are starting with 2D mensuration. Now in 2D mensuration, let me first get started with the idea of a circle. So there is a circle over here, and this line that is joining 2 points on the circle, this is known as a chord. So we have AB, and this AB is a chord. This AB divides the circle into 2 unequal halves. So this region, the green region that I've shaded over here, that is one small part of the circle. We call it the minor segment. And the part that is left, let me shade it also. This part that's right over here, this part that is the major segment. So we are dealing with 2 unequal areas, and we are talking about a major segment and a minor segment. Actually, this one is major. So that one was minor, this one is major segment. Now let me draw another diagram. Again, using a blue circle right like this. And let me draw a line from the center to the circumference, a line from the center to the circumference, a chord between these 2 points, and let me do some labeling. This is the radius, this is the center, this is again the radius. These 2 radii are equal. Therefore, later on, if I will be dealing with some angles, these 2 angles will be the same. What else is there? This line, this is A, this is B. The purple line, that is the chord AB. And if I talk about this thick green line right over here, the curvature, that is the arc AB. Now, what else do I have? I have this region over here that I'm shading. This is a segment. So let me just take out an eraser and let me just erase this like this. So therefore, this is the segment. And what else is there? We have a segment, and then we have a triangle. And over here, this triangle plus the segment, that makes up a sector. So this shape over here, from the center to the circumference, and then the arc length, and then again the radius, that is a sector. Now let me draw a sector over here. So we are talking about a sector, and how is the sector made? So let me draw a line like this. Let me draw a line like this. And then let me draw an arc going this way. So that's how a sector is made. This is radius, this is radius, this is arc length. That is the symbol I'll use over here. And there will be an angle over here. So some basic trigonometry will be used. So let me write this thing over here. That will be theta. Now, how would we calculate the area of the sector, the area of the segment, and all these things we need to learn. But before that, or maybe after that, we will talk about some basic trigonometry. So first of all, let me talk about arcs, and we are talking about arc length. The symbol is S. The formula is S is equals to theta degrees over 360 degrees into 2 pi r. Now, why do we have this formula? The reason is that if we are talking about a circle, and if I divide this circle into 4 pieces, so this is dividing into 2 pieces and then dividing into 2 more pieces. And maybe if I talk about just one region, that is like a quarter circle. So we know that the area of this quarter circle, or let me first talk about the arc length. If I talk about this arc length that's over here, so the arc length of this quarter circle will be 1/4 that of the circumference of this circle. Make sense? Because the circumference is the whole thing, we are taking only 1/4 of it. So what is the angle over here? The angle over here is 90 degrees. 90 over 360, that's 1:4. That's how you get this. Similarly, if we talk about area of sector, so now let me write down that another line over here, and let me erase this thing. So over here, let me write down the area of sector. Let's call it the symbol A. So area is theta over 360 degrees multiplying with pi r square. It's so simple. The ratio of the angles with respect to 360 degrees multiplying with circumference gives you the arc length, because arc length is part of the circumference. And the ratio of angles with respect to 360 degrees multiplying with area of circle, that will give you area of sector. Now over here, quarter circle, area of quarter circle is 1/4 area of circle. So this is area of circle. This is circumference of circle. Maybe I'm talking about a semicircle. So the arc length is half of the full circle. What is this angle? 180. Similarly, area of semicircle, that will be half of circle. How do you get that half? That's 180 divided by 360. I hope this is all good, all clear. Just acknowledge it on the WhatsApp. Let me just go to the WhatsApp. Okay, Ji. It's all good, all clear. Now, what can we do with this? First of all, we can do some basic questions. And even before that, let's revise basic trigonometry. Now, if we revise basic trigonometry, so we should be well versed with right angle trigonometry as well as non-right angle trigonometry. When we talk about right angle trigonometry versus non-right angle trigonometry, so this is right angle triangle versus non-right angle triangle. Now let me draw a right angle triangle over here. And this is the height. This is the base. And this is the hypotenuse. So this is right angle. This is an angle theta. This is side A. This is side B. But instead of A and B, let me write this as opposite with respect to theta. This is adjacent with respect to theta, and opposite of 90 is hypotenuse. Now, first of all, we need to talk about Pythagoras theorem. Hypotenuse square is equals to opposite square plus adjacent square. When we are talking about opposite, we can also call it perpendicular. When we are talking about adjacent, we can also call it the base. Perpendicular height, that is a better term. And hypotenuse remain as hypotenuse. What else are we interested in? We are interested in sine theta, that is opposite over hypotenuse. We are interested in cosine theta, that is adjacent over hypotenuse. We are interested in tangent of theta, that is opposite over adjacent. This is what we are interested in. And naturally, don't forget area of triangle, that is half into base into height. Height means perpendicular height. And when we talk about non-right angle triangles, so let me draw a non-right angle triangle. One line is going this way, the other line is going this way, and then there is a third line going this way. So now let me write it. And we are writing this thing as angle point A, point B, point C. Similarly, angle A, angle B, angle C. Instead, in front of A is small a, in front of B is small b, in front of C is small c. So the big ones, A, B, and C, they are the angles. And the small ones, A, B, and C, they are the sides. So if I talk about cosine rule, that is two sides and included angle. If I have two sides, and if I have this included angle, I can find the third side. Or if I have all three sides and I'm interested in finding angle A, I can use cosine rule. So cosine rule is A square is equals to B square plus C square minus 2BC cosine of A. And if the need arises, I can also write this thing as cosine of A, that is A square minus B square minus C square divided by negative 2BC. Remember, if cosine is positive, the angle is acute. If cosine is negative, the angle is obtuse. This is with respect to this thing, this bracket over here. If this bracket is positive, angle is acute. If this is negative, the angle is obtuse. So let me just move this thing comfortably below this, like this. What about sine rule? If I talk about sine rule, that is the relation between any side and its opposite angle. Any side and its opposite angle. Any side and its opposite angle. So therefore, sine rule can be written as A over sine of A, B over sine of B, C over sine of C. Some people, they prefer to write it the other way around. Sine A over A. And then we have again a sine, no cosine. Sine B over B. And then we have sine C over C. At a time, we use only two of them. For example, I could be using these two like this. I could be using these two like this. And last but not the least, that is area of triangle. That is half AB sine of C. That is how we use all this. So let's first recap what we have studied so far. And I hope that all these, what you call the PDFs that I upload, that is of any use, that you are copying it from there, because during our class, we don't have time for copying. There is so many things going on. The first thing was about the major and the minor segment, AB being the chord. And one more thing, People ask this question. Is diameter also a chord? The answer is yes. A diameter is a chord which passes through the center. So it passes through the center of the circle. And then we talked about chord and arc and sector and all these things. And then we talked about how these formulas came into being. It's basically the ratio of the angle with respect to 360. Multiply it with circumference, you get the arc length. Multiply it with area of circle, you get the area of circle, you get area of sector. And then basic trigonometry review. Now, let me first do a basic question, and then I'll directly go to the past paper questions. So something like this. And then let me draw two lines, one line like this. Let me just draw it better. And then, okay, let me draw this purple line over here. Okay, so now we have O, A, B. This angle is 60 degrees. The radius is 10 centimeters. I am interested in few things. I might be needing more space, so let me just copy this. And let's move to the next page. And let me just paste it over here. Now, in the first one, I'm basically interested in perimeter, length type things. So I'm interested in length and arcs and perimeter. Now, first of all, let's look at this diagram. This is 10, therefore this is 10 because this is also the radius. This is 60. Now, the very first thing that we should remember is that if we are dealing with an isosceles triangle, this is 10 and this is 10. And remember, this is theta and this is theta. So this isosceles actually becomes an equilateral triangle. So mark my words, isosceles triangle with 60 degrees actually becomes an equilateral triangle. Why? Because just do the basic math. This is 60 plus theta equals to 180. 2 theta equals to 120. The difference between 180 and 60. Therefore, theta is 60 degrees. Therefore, you have proven that such a triangle that's drawn up, that's an equilateral triangle. That means without any calculation as such, chord AB has a length of 10 centimeter. Now, if someone wants to go the long way without earning any extra marks, they can do the cosine rule. If they apply the cosine rule, they will write AB square is equals to 10 square minus 2 into 10 into 10 into cosine of 60 degrees. Now, cosine of 60 degrees is half. Half over here, 2 over here. It cancels out. You are left with 10 into 10, which is 10 square. And then we have 10 square over here. We have 10 square over here. Again, these two 10 squares cancel out. We are left with 10 square over here. That is AB square. In other words, AB equals to 10 centimeter. The same thing as we have proven geometrically. So that is the first part. The second part, that is the arc length AB. That is theta over 360 degrees into 2 pi r. Now, I'll work in terms of pi. I'll treat it as a paper one question. This is 60. This is 360 into 2 into pi into 10. So therefore, this is 1 over 6 into 2 into pi into 10. Let's cancel it out. 2 ones are, 2 threes are. This answer comes out to be 10 pi over 3. or I can write this thing as 3/1/3 pi centimeters. I'm treating it as a paper one question. What else is there? The third part, that is perimeter of minor sector. Now, if I talk about this minor sector, I'll be using this angle 60 degrees. So the perimeter is 60 plus 60 plus this arc length. So the perimeter is 2r plus s. That is 2 times 10 plus 10 pi by 3. That comes out to be 20 plus 10 pi by 3. Use a bracket and write centimeters over here. What if someone asks for the major arc length, just the major arc length, that is this thing. But then we have to use this angle, which is 300 degrees. So the fourth part, that is a major arc length. Now, there are two ways of doing about it. The first one, the reflex angle that I need to use, that is 300 degrees. Therefore, major arc length, that is 300 over 360 into 2 into pi into 10. That is 5 over 6 into 2 pi into 10. That is 2 ones are, 2 threes are, that is 50 pi over 3 centimeters. That's one method. Now let me use another method. That another method is alternatively, I can say circumference of circle minus arc length AB minor will give me arc length AB, which is major. Make sense? This is the arc length minor. This is the whole circle. If I subtract this portion, what am I left with? I am left with this portion, which is the major arc length. So circumference of the circle, that is 2 into pi into r, and arc length of minor, this thing, the minor arc length, that is 10 pi by 3. So this is 20 pi minus 10 pi by 3. This is 60 pi minus 10 pi divided by 3, which comes out to be 50 pi over 3 centimeters. It's the same answer as this. So now this is all good. This is all done. Let's use the same diagram. And this time we are interested in finding areas. Now, area of what? Area of triangle, area of sector, area of segment. Now, first of all, let me just do a bit of shading. So this thing over here, that is the area of the minor segment. Let me just erase this thing. Okay, so first of all, let me ask you the area of triangle OAB. Since it's a non-right angle triangle, so use half AB sine of C. This is half into 10 into 10, because this is 10 centimeter, this is also 10 centimeter into sine of 60 degrees. Now, this is a paper one question. Without the calculator, they will give us sine of 60 is square root 3 over 2. So let's use this. This is half into 100 into root 3 over 2. That is 100 divided by 4. This 2 and this 2 becomes a 4 into root 3. That comes out to be 25 root 3 centimeters square. That's how this part is obtained. Let me calculate. Have I labeled the areas? That's part 4. So let me label this thing as part 5. Actually, that's part 4. So this is part 5. Part 6. That is area of sector. That is theta over 360 into pi r square. That is 60 over 360 into pi into 10 into 10. 10 square, I've written it twice. This is the zeros cancels out. And let me go back. So this is 61s are 66 are, and then 5 and 3. So that becomes 50 pi divided by 3 centimeter square. That is the area of the sector. Now we know that this whole thing is the sector. It's made up of a triangle in a segment. That means if I subtract the triangle, I'll get the area of the segment. So let me write it. 7th part. Area of sector is basically area of triangle plus area of segment. Therefore, area of segment, if I make this the subject, that is this minus this. That is area of sector minus area of triangle. Area of sector, that is 50 pi by 3 minus area of triangle is 25 root 3. Leave the answer as it is because this is a paper 1 question. Now, we have spent all this time understanding this in thorough detail. Now it's time to check our skill level using these questions. So the very first question for 2 minutes, I want you to try it out. Now, this is a straightforward question. It's a paper 1 question. The question says OAB is a sector of a circle radius r, AOB is 60. Find in its simplest form an expression in terms of r and pi for the area of the sector. So for area of the sector, that is 60 over 360 degrees into pi into r square. They are saying in terms of r and pi. So it will remain as it is. That is 1/6 of pi r square. That is 1/6 of pi r square. The second part, the perimeter of the sector. This is r, this is r, this is the arc length. So first find the arc length. That is 60 over 360 into 2 pi r. That is 1/6 into 2 pi r. That is pi r over 3 or 1/3 pi r. But they're asking for the perimeter. That is radius plus 1/3 pi r. That is 2r plus pi r over 3. This is 2r plus pi r over 3. Make sure to use brackets where needed. So this part is done. Now, the second part also you can try out. That's everyday maths. So why don't you try it out? Take around 3 minutes. Now let's look at this question. The question says, the diagram shows part of an earring. It's in the shape of a sector of a circle of radius 3 centimeter, angle 45 degrees. So this is the earring. This angle is 45 degrees and this radius is 3. From which a sector of radius 2 centimeter, angle 45 has been removed. So this has been removed. Calculate the shaded area. Give your answer in this form where A and B are integers and as small as possible. That means in the simplest form. Now, first of all, there are 2 sectors over here. Let me write one of them as sector 1 and the other one as sector 2. They both have the same angle, which is 45 degrees over here. This is 45 degrees over here. Let me do a small calculation over here. That is 45 over 360. So we know that 90 into 4 is 360. 90 itself is 45 into 2 into 4 is 360. Therefore, 45 over 360 is 1 over 8. So this is 1, this is 8. Why do I need this? Because if I calculate area of the sector 1, that is 45 over, let me just enlarge this, 45 over 360 degrees into pi into 3 square. Area of sector 2, that is 45 over 360 degrees into pi into 2 square. So let me just remove the small multiplication sign from here. Let me use brackets instead. This is 1 over 8. This is pi into 9. This is 1 over 8 into pi into 4. Do not reduce. The difference is the shaded region. Area 1 is bigger, area 2 is smaller. So this is 9 over 8 pi. This is 4 over 8 pi. Why do you think I ask you not to reduce it? Because if the denominators are the same, I can simply subtract 9 minus 4, which is 5 pi over 8. This is as small as possible. It's in the form A pi over B. So they have not asked it, but we have written it. A is 5, B is 8, and that is how we are getting the answer 5 over 8 pi centimeter squared. Now the second part is about basic everyday maths. The question says the earring is cut from a sheet of silver. The mass of 1 centimeter square of the silver sheet is 1.6 gram. By taking the value of pi to be 3, we know that pi is 3.142 and so on. It's an irrational number. By taking pi to be 3, estimate the mass of the earring. So this is some basic maths that we have to do. 1 centimeter square has a mass of 1.6 gram. And we have the area of earring, that is 5 over 8 into 3, that is 15 over 8. So 15 over 8 centimeters square will have an area of A. So cross multiply. So basically this multiplies with this multiplies with this. So A is 15 over 8 into 1.6. Now keep in mind, it's a paper 1 question, so calculator is not allowed. So write this thing as 15 over 8 into 16 over 10. Now simplify. 5 3s are, 5 2s are, 8 and 2 is 16. There is 16 at the top. So this cancels off and we are left with 3. And I don't know why I used A. M would have been better. So let me use M for the mass. This is M, this is M, this is M. That is 3 grams. That is the answer for this particular part. So again, a paper 1 question. Now, try this one out. This one is tricky. I want you to think and try. Now, this question looks a bit different from others. The question says, in the diagram, ABCD is a diameter of the circle center P. Now, this is P. This is 2x. This is 2x. This is 2x. So the diameter has a length of 6x. Half of that is the radius. So first of all, radius is 3x for the big circle. So we have this thing, let me highlight it like this. This is 3x. And then this thing is again 3x. Now that is the first thing. Find an expression for the circumference of the circle. For the circumference of the circle, that is 2 pi. And let me write a capital R. This is 2 pi into 3x, which comes out to be 6 pi x. That's the first part. Then it says the perimeter of the shaded region. This is the perimeter of the shaded region. consists of two semicircles whose diameters are AB and CD. So AB is diameter, CD is diameter, and two semicircles whose diameters are AC up till here, this is C, AC and BD. Basically, let me just erase this. What we have over here is that we have two circles, this and this. I can add it and make it into one circle. So let me first write it and let's see what am I looking for. So let me just highlight it like this. This is one, not exactly the same, but just giving you the idea. And this is the other one, like this. So now if I join these two, I get a circle. Now, if I get this circle, let me write this as AB. That's the same thing as CD. AB has a diameter of 2x. Therefore, the radius is x. So this radius is x. And let me focus more on this. Let me erase all this thing. And then I have another semicircle, which is like this. The radius is 2x because the diameter is 4x. Similarly, this is also 4x over here, the diameter. So let me draw this thing a bit bigger. And I can say that this thing over here has a diameter of 4x. So I can label it AC or BD. AC or BD. So let me write AC. That's the same thing as BD. I have joined it. The radius is how much? The radius is 2x. Now, what am I interested in? Find an expression in terms of x and y for the area of the shaded region. So basically, out of this, if I subtract this, I have this. That's the same thing over here. Now, if I join this, let me just draw it like this. Let me draw it like this. Are you getting the idea? So now this is the big circle minus the small circle that will give me everything. So let me draw a big circle over here, just to give you the idea. So over here, if I draw, let me use a blue marker. It goes like this and like this and like this. That's the big circle. And let me draw the red circle over here like this. Now, do you get the idea? So basically, this is like this. Hold for a second. So let me just use this marker. So now this purple region over here, and there will be a purple region below that also. So this same purple region will be over here. I have transformed this. I have shifted this. I have just used my brain a bit more. So now, what is this? This is the area of the big circle minus area of the small circle. That will give me everything that's shaded. So that's the only working that you need. So area of small circle, that is pi x square. Area of big circle, that is pi into 2x square, which is 4 pi x square. Therefore, the difference is the area of shaded region. So therefore, that comes out to be 3 pi x square. That's the answer. Just have a good look and acknowledge if this is all good, all complete. Okay, this is again from the past paper book. Now, this question over here, let me send it to you. I want you to try it out. This time, this is a paper 2 question. So grab your calculator and then try it out. I can make it smaller also over here. And I'll pause the recording. Now, in this question, which is a paper 2 question, the question says, in the diagram, OBC is a sector of a circle, center OBOC is 60. So OBC, and it goes like this. And then this angle is 60 and the radius is not given as yet. AB and DC is 6. AB is 6, DC is 6. What is OA? What is OD? We don't know. Show that AD equals to 6. Now that's the first thing. AED is a semicircle with AD as the diameter. So AED is a semicircle with AD as the diameter. Now it says, show that AD is equals to 6. Now this is related to what we have studied. That was about that isosceles triangle. This length and this length is the same. If these two are the same, then this angle over here, this green angle and this green angle should be the same, and that will be 60-60. So always remember the rule, isosceles triangle with 60-degree angle becomes an equilateral triangle. So therefore, if AB and DC is equals to 6, so AB is 6 and DC is 6, and what else is there? Show that AD is equals to 6. So now we have to write this thing. What else is there? The sector is 60 degrees and midpoints. The midpoint is there. So this is 6 centimeter. This is 6 centimeter. Therefore, this is 6 centimeter because it's an equilateral triangle. So you should underline the statement which I missed out. A and D are midpoints of OB and OC respectively. So that thing is done. The first part is done. The length of the arc BC is n pi. The length of arc BC is n pi, find n. So now this whole thing is 12. This angle is 60. Let me write it. So therefore, arc length BC, that is 60 degrees over 360 degrees into 2 into pi into RR is 12. Now, first of all, let me get rid of the zeros over here. And then we have 6 ones are, 6 6 are. And then this 6 and this 12 cancels out. So 6 ones are, 6 twos are. And 2 and 2 is 4 pi. And they have written this as n pi. So the value of n is 4. That's how you should write it. Now, even though it's a paper 2 question, it looks like a paper 1 question. Now it says, find the length of the arc AED, length of arc BC. So AED is this much and BC is this much. So first of all, length of arc AED, I can use the concept of circumference of semicircle, which is half that of a circle. So half of 2 pi r, which is simply pi r. So this 6, this is the diameter. Therefore, the radius is 3. So therefore, this is 3 pi, leave it as it is. Similarly, length of arc BC, that is 60 over 360 into pi into r square. What is r? That is 12 square. So therefore, the zeros cancel. 6 ones are, 6 6 are. 12 square is 144, or I can even write this thing as pi into 12 divided by 6. So therefore, 6 ones are, 6 twos are, 2 into 12 is 24. This is 24 pi. So the numerator is 3 pi. Let me write it over here. Numerator is 3 pi. Denominator, again, it's a paper 1 question. It's 24 pi. What is the ratio? The ratio is the pi's cancel out. 3 ones are, 3 8s are. So the answer is 1:8. That is the ratio. Find the area of sector BOC. What is BOC? BOC is this big sector over here. We need to find the area of this sector. So area of sector BOC, that is theta, which is 60 over 360 degrees into pi into 12 into 12. 12 square, I'm writing it as 12. The zeros cancel. 6 1s are, 6 6 are, 6 1s are, 6 2s are, 2 into 12. That is 24 pi. One more thing. I just made a small mistake. Let me correct myself. This is circumference. So this is also circumference. So this is 2 pi r. So let me just erase this thing. That's my mistake. So let me erase it over here. So therefore, this is, let me erase this thing. Okay. So this is theta, which is 60 over 360 degrees into 2 into pi into r. R is 12. So therefore, the zeros cancels out. 6 1s are, 6 6s are, 6 1s are, 6 2s are, 2 into 12. That is 2 into 2 is 4 pi. So 3 pi over 4 pi. This comes out to be 3 over 4. Coming back to this. This is 24 pi. Hence, find the area of the shaded region. So area of shaded region is area of the big sector minus this triangle minus the semicircle. So let me calculate this thing. Area of triangle OAD. That is half AB sine C. Now you need a calculator, or let me write it in the exact form. I'll use this thing, sine of 60 degrees. That is 0.8660, or I can write this thing as √3 over 2. So this is half into 6 into 6 into √3 over 2. I'll use the calculator later. 6 into 6, 36. 36 divided by 4, that is 9 √3 centimeters square. Area of the semicircle. So area of semi, that is half of pi r square, pi into 3 square. That comes out to be 9 pi over 2 centimeters square. So now I'll use this, and then I'll subtract it from the whole thing, the whole sector. So area of shaded, that is area of the big sector, minus area of triangle, minus area of semi. So this is 24 pi. We can use the calculator at the very end. Minus area of triangle, that is 9 √3 and 9 pi over 2. 9 √3 minus 9 pi over 2. Either I can leave the answer as it is, or I have to use the calculator, work in 4 SF, then final answer to 3 SF. So now a lot of questions are there. You need to try them out. The answers are also here, and they are also in the topical past paper. Till the next class, take care.